Continuing to move forward in our study of fractions, you see familiar terms here. We have improper fraction to mixed number. We now know what both of those mean. We know what they look like. I've written here an improper fraction. We know it's improper because the numerator is larger than the denominator, so it's improper or difficult to understand really what it's talking about. This is that fraction's mixed number form, which is obviously much easier to understand. So how do we get from one to the other? Because there's a lot of that happens in math. You're going to have to do this a lot of times in your math careers for the next several years. So let's learn how to do it. The good news is you already know the procedure. It's called division that will do that you'll use most of the time to convert these. In this lesson, we're going to have you do it visually. Again, we're wanting to make a visual connection to what's actually going on so you understand what you're doing rather than just memorizing a process for doing it. You will eventually memorize the process, but we want you to also have a good visual representation in your brains about what's going on. So let's revisit the Kit Kat bar for this. So the scenario is this. I get 5/4 of a Kit Kat bar. Obviously, that's more than 1. We've studied 1, so we know 4/4 would be 1. This is bigger than that. So it's going to go bigger than 1, and I already showed you the mixed number. But how does this work in conversion? So let's start divvying up the pieces. So I get 5 out of 4 pieces. The 4 says how much my whole needs to be divided up so I can make the comparison. 1, 2, 3, 4. Not quite there yet. I've got to have more, so I need another Kit Kat bar. One, 2, 3, 4, 5. Now that's how much I get, a little bit more than 1. Maybe mom bought 2 Kit Kat bars and gave one to me, one to my sister. My sister didn't want all of hers, so she gave me 1 piece. So I actually got to eat 5/4 of a Kit Kat bar, a little more than 1. Now we recognize this as 4 out of 4. We know that fraction is 1, so this represents 1 whole. And by now that's painfully obvious to you. And then what's left of this one, we know this is 1/4. That's how much we get. So there's our mixed number, 1 1/4, and that's exactly how it comes to be. It's exactly how that conversion is made visually or practically. Now let's look at, because we're going to, if we're comparing a really large fraction, like maybe if the fraction was 29/4, we're going to have to draw a lot of Kit Kat bars to make that conversion, and it's no longer convenient. So we need to have a quicker process for efficiency, because we don't want to spend all day drawing pictures in math. Maybe we do, but probably not of Kit Kat bars. So the conversion, really, the simple way to convert is division, like I told you. This actually is a division, or a fraction bar can also mean division. We can see it as that. This can be read as 5 divided by 4. So we put it into the division algorithm. This is 5 divided up 4 ways. And then you just go through the division process. You should already know this, so we're just going to talk through it real quick. How many times will 4 go into 5? It'll go once. 1 times 4 is 4. So we take out 4 of those, and we have 1 remaining of the 5. So we have 1 with a remainder of 1. And that's how we wrote it when you learned division. But now, since we're converting from improper to a mixed number, we're going to put it in fractional form. And fractional form really is just like this, 1, and then the remainder is 1. The denominator is still going to be the same denominator it was over here, which was your divisor in the division problem. So it always follows that procedure, and you're going to practice this enough that you'll have that down. Let's look at one more simple problem just to demonstrate this again, and then we'll let you get to the practice. Let's do 7 halves. So the modeling, I'm going to break up whatever I'm modeling is going to be in 2, so I just need 2 segments. And I know that I get both of those up to a point, so that's 2 halves. Obviously I've got to go further. So let's draw another one. Now I'm up to 3, 4 halves. We're not to 7 yet, so keep going. Draw another one. 5, 6 halves. Almost there, but not quite. So draw another one. There's our 7th half. So we have 1, 2, 3 wholes, and then 1 out of 2, or 1 half. So our mixed number is 3 and 1/2. Again, in this lesson, we're going to have you model a few easy ones. Just do it. It shouldn't be that hard. You don't have to use squares. You can use circles or whatever shape you want to, but we're going to have you model some. Now let me model the procedure, the algorithm. So it's just division. Remember, this is 7 divided by 2. The division bar can also mean, or the fraction bar can also mean division. 7 divided by 2 looks like this. 7 divided up 2 ways. So just go through the process, the algorithm. 2 goes into 7 how many times? Well, I know 2 times 3 is 6. I know 2 times 3 is 6. Sorry. 2 times 3 is 6. 7 minus 6 is 1, so I took care of 6 of them. I have 1 remaining. So in the old days, this would have been 3, remainder of 1. But now we need it to be in fractional form, so it's 3 and 1. Remember, the 3 is the answer, the 1 is the remainder, and the half is the denominator that was the same as the original fraction. It's going to continue to be the same. So that's how you convert procedurally from one to the other. Get through this quick practice section. I think you'll have it down, and then we'll move on to more complex problems.